So here's the probability question. Let's see if we can get this through this without Rosalie getting angry with me. So I'm going to look first of all at the probability of the spinner. Okay, so we've got a spinner. Okay, spinner is spinning. This tells me the probability of that spinner. So right, the first thing I've got is I've got four unknowns. Well, I need to turn them into something I can actually use. But I do know that if I add all these probabilities together, A plus B plus C plus D, it's got to equal 1. Right, so now the question says, it gives me a conditional probability. It tells me that if the probability of S, given that X equals some value, is equal to K over X. Now let's remember that S is actually throwing the ball into the bin. So this is the ball being thrown into the bin and X taking a certain value. So that tells us it's Kx and K is a constant. Right. Now that's a conditional probability. We know that the probability of S given that X takes some value must be equal to the probability of S and X taking that value divided by the probability of X taking that value. Okay, this is our conditional probability formula. So let's rewrite that. We're told that the left-hand side is actually K over X, and the right-hand side, we don't know what this numerator is, but we do know what the denominator is. For example, when X is 20, it's A, so that would be A. Okay, and we're told that all of these are the same, so this doesn't change. Now the question says to me, I've got to show that this C equals 8/5 of B. So what I'm going to do is I'm going to make X equals X. I'm going to do that for X equal to 80, because that's where I get my C from, and I want C. So this is going to be C, and if that's C, then X must be 80, because those are the two values I'm given at the beginning. Okay, so I've got that. So now, if I want this thing that's constant, the probability of S and X equals a specific value, that's equal to C times K over 80. Right, then the other part is when it's B. So now, again, the only thing that's going to change is my C here is going to be B, and my X is going to be 50. So if I do the same thing, that means that P of S and X being equal to a certain value is going to be B times K, same constant, over 50. And these two things are the same because that's the condition I'm given. So that means that CK over 80 is equal to BK over 50. And therefore 50CK equals 80BK. And what can I do? I can divide these by 10, and I can divide by K, because the K at the moment is not important. Right, so now that means that I can say that C is equal to 8/5 of B. And I've shown that first part. Now I'm going to find the probability distribution. Remember, the probability distribution means that I've got to rewrite that table with the values. Okay, but I'm going to have to work out what some of these values are first. root. So what do we know? We know the x values. This is 20, this is 50, this is 80, this is 100. Right. So now we know C is 8/5 of B. So I'm going to rewrite that as 8/5 of B. Okay, right. So now I need to find something for D, something for B, something for A. So I do the same thing I've done above. Okay, that means that for A, the probability of S and X equals a specific value would be A times X over 20. And if I rearrange that, I will get that A is equal to 2/5 of B. Okay, for 50, that's actually B itself, so that's fine. That means I can just write B. For D, I get D when X is 100, so that means it's D times K over 100. Again, I rearrange that, and I will get that D is equal to 2B. So now I've got everything in terms of one variable. And I know, as it's the distribution, that this equals 1. If I add all my b's together, I end up with 5 b's being equal to 1. So b equals 1/5. So now what I do is substitute that back into my equation. And now this becomes 2/25. This becomes 1/5. This becomes 8/25. And this becomes 2/5. Those are my probabilities. Okay, we've used the conditional probability. We've written everything in terms of one variable. We've used the fact that a distribution adds up to 1. And we've found what b is worth to find every individual probability. Okay, right, so hopefully Rosalie's not angry with me yet. Now it says Nav tries a large number of times to throw the ball in the cup from a distance of 100 centimeters. So we're only looking at x equal to 100. Okay, x equals 100, which we know the probability is 2/5. Okay, but it says he successfully gets the ball in the cup 30% of the time. Now this tells us that the probability that she gets it in the cup, given x is equal to 100, is 0.3. That's simply what we've been told in the question. We've got to give a reason why the model might not be suitable. Right. Well, what's the only thing we haven't worked out? We haven't worked out what k is. So remember, this conditional probability was k over x. So in this case, k over 100. And we've been told that the answer to that is 0.3 from the question. So that means that k is 30. So now we've got no unknowns left. We know what k is. Now, why might it not work? Well, if you think about it, I know that the maximum value of any probability question is 1. Is there a value that gives me more than 1? Well, if I've got k, which is 30, divided by a number which is less than k, I'm going to get an answer of more than 1. And I have got a value that's less than 30, 20. So 30 over 20 is more than 1, and therefore it doesn't work for all values. Right, I hope that has made it clear. If not, soldier on, or come and see me.